Hello, I wanted to talk about a recent project of mine. So just to preface this, I make pen plotting art. So I will make code in JavaScript or Python or some other languages, create some code that basically generates kind of abstract forms or interesting data visualizations, and then using a pen plotting machine will plot the output. So what you're looking at here is a framework I built in JavaScript, which basically takes in a 3D function and then sort of pixelates it and visualizes it in a sort of a isometric perspective, like a 3D kind of pixelated view. What you're looking at here is one of the plots with the same sort of 3D visualizing framework in JavaScript, but I used something called Perl and Noise. Now, Perl and Noise is a way to create I guess a sort of like random texture, but in a continuous and flowing way. So it gives this really nice terrain looking feel to it. Now I showed this to a close friend of mine, and they pointed out that this would be really cool if we could actually, map real life terrain. Now I thought that was an amazing idea, but I was fairly skeptical that could even be done. After scouring the web, I found out that NASA have a lot of data in the public domain. So I had a look through at some of the culturally significant terrains that people appreciate. One of which was Mount Fuji. So I took the coordinates of Mount Fuji, and then in the NASA tool that I was referencing, I found a data set, and you can see this sort of like heat map colored square represents a data set that they had of surrounding Mount Fuji. So I downloaded it, and here is the data in Python. I've just used a library called Seaborn to visualize the data, and this is a heat map. So basically, the brighter the pixel is, the higher the altitude. And you can see in the sort of lower right-hand quadrant, there's a really bright spot. That represents the peak of Mount Fuji. And this is what I want to be feeding into my JavaScript framework. If you remember at the beginning of this video, I showed some of the examples of the plots with the 3D visualizer, and it was, around 80 bars or blocks in terms of depth and width. When I say blocks, I mean those vertical bars that I'm using to represent the height of the function at a certain point. I used around 80 because, well, obviously we're limited to how thin of a line a pen can draw. If I was doing hundreds or thousands of those bars, the pens wouldn't be able to capture that. It just wouldn't look, it would just be a mess, to be honest. So I needed to think about that when approaching these data sets. So the data set originally had around 3,000 by 3,000 data points in terms of size, as a matrix. So I had to reduce that down. So the way I did that was I cropped the data around the Mount Fuji, and then I just lowered the resolution. So now what you're seeing here is, basically it's a matrix 80 by 80, and yeah, now this is basically ready to be fed into the framework. And so this is the output. This is the final plot. This is Mount Fuji visualized using a sort of a 3D function visualizer, like a pixelated function visualizer. And yeah, now it's time to actually plot this with the pen plot machine.